All right, I am making this video to go over the test review so you can have the answers while I am out today. So we're going to go through this really quickly. All right, so the first one, you randomly choose one of the tiles shown, determine the theoretical probability of the event. All right, so for the first one, choosing an even number greater than 7. All right, so how many even numbers are greater than 7? All right, so 8 appears to be the only even number that's greater than 7. So I need a number past 7. So 8 is my only one. So I have 1 out of 9. All right, choosing a number divisible by 3. All right, so how many numbers can be divided by 3 and have no remainder? So 3 is divisible by 3, 6 is divisible by 3, and 9. All right, so that's going to be 3/9, or you can simplify that to a third, because 3 goes into 3, and then 3 goes into 9. All right, number 2, you check 20 batteries. 14 of the batteries do not have a charge. What is the experimental probability that the next battery you check does not have a charge? All right, so I need to do, all right, so how many batteries don't have a charge? So that's 14, and then I've checked 20 total. All right, so what number goes into both of these? I know 2 goes into both of these, so I can reduce this to 7/10. All right, so this is one that a lot of you have been having trouble with, so this is a good time to make sure you're paying attention. All right, so out of the next 70 batteries you check, how many do you expect to not have a charge? So for a question like this, what I need to do is, all right, so 70 next that I check. So expect not have a charge. All right, so what I need to do is take my experimental probability, which is 7/10, and I need to multiply that by the number it gave me here, 70. And 7/10 times 70 is going to be 49. All right, next one. These cards are the same size and shape. They are placed inside a bag. A card is selected, then placed back inside the bag. This is done 18 times. The card E is selected 8 times. So what I'm going to do is highlight what I think is important. So how many times we did it total, and then E is selected 4 times. All right, so theoretical probability of selecting a card with E is what? So there's 1, 2, 3, 4, 5, 6 cards. So that's going to be 1 out of 6. All right, an experimental probability of selecting a card with E. So for my experimental probability, I got E, let's say 4 times out of 18. Can you reduce 4/18? Yes. It's going to be 2/9. All right, let's move on to number 4. All right, you flip 3 coins 50 times and 3 tails occurs 6 times. What is the experimental probability you flip 3 coins and get 3 tails? All right, so right here it tells me 3 tails occurred 6 times. of 50, right? So that means 6 times out of 50, I got what they were looking for. And you can simplify that to 3/25, since 6 and 50 are both divisible by 2. All right, how many times would you expect to get 3 tails out of 200 trials of flipping 3 coins? All right, so this is the same as this previous question right here at B, where you have to get your experimental probability and then multiply that by the number of trials we're doing. All right, so 3/25 times 200 is, I'm just going to plug that into my calculator right here. That is 24. All right, makes sense? All right, let us keep going. All right, you throw 2 sticks 15 times and record the results. Use the table to find the experimental probability of the event. So tossing 2 blue. So we got 2 blue 4 times. And remember, it told us how many times we did it, 15. So 4/15. Sorry, my 5s are terrible. 4/15. Right, and can't simplify that anymore, so we'll just leave it like that. All right, next one, tossing 1 blue and 1 pink. All right, so that happens 8 times. So that's 8 out of 15, and can I reduce that? Nope. All right, let's move on to number 6. A fair number cube. So remember, when it says fair number cube, we're just talking about a dice, like a 6-sided die. That's what fair number cube means. So don't get caught up in what exactly do you mean by fair number cube. A fair number cube was rolled 40 times. The number 5 was rolled 8 times. Which statement best describes the experimental probability and theoretical probability of the fair number cube landing on 5? So for just like a regular number cube, so there's only 1 5 out of 6 spots, so that's going to be 1/6. And then the number of times we landed on 5 was 8 out of 40. So remember, I got those numbers from here and here, and then a dice has 6 sides, so that's where I got 1/6. All right, so can you reduce 8 40th? Yes, because they're both divisible by 8. Yes, they're both divisible by 8, so you get 1/5. All right, so we're looking at, choose a different color here, 1/5 and 1/6. All right, so let's look at our options. The experimental probability, I'm going to start with D. The experimental probability and theoretical probability are both equal. I know that's not true, so I'm going to cross this one out. The experimental probability of 1/6 is greater than the theoretical probability of 1/5. Well, I know 1/6 is not greater than 1/6, so I know that's wrong. The experimental probability of 1/5 is less than the theoretical probability of 1/6. Well, I know that's wrong too, because 1/5 is bigger than 1/6. All right, so my answer is going to be A. The experimental probability of 1/5 is greater than the theoretical probability of 1/6. So that's going to be my answer. All right, so let's keep on moving. All right, you check 30 containers of yogurt. 7 of them have an expiration date within the next 3 days. Sorry, that's my phone. What is the experimental probability that a container of yogurt will have an expiration date within the next 3 days? All right, so can go back up. So 7 of 30. So that tells me it's going to be 7/30ths. All right, can you reduce that? Nope. All right, so this is another one of those problems where we're taking the experimental probability and then using that to find how many times a certain event would occur if we do it like X amount of times, like 200, 400, 1,000, million, whatever number you can think of. So out of 120 containers of yogurt, how many would you expect to have an expiration date within the next 3 days? So 7/30ths, that's going to be times 120, and that's 28. All right, next one. A plant produces 1,200 packages of grapes. An inspector randomly chooses 24 packages and discovers that 8 of the packages have broken seals. How many of the 1,200 packages of grapes would you expect to have broken seals? So this is another one where you're doing that same thing. So what I'm going to do is highlight what's important. So 1,200 packages of grapes, 24 packages, 8 were broken. All right, so I need to do, so 8. I'm writing this out like fully to help you guys understand a little bit better. All right, and you can reduce this to 1/3. All right, so 8/24. Oops. And you can reduce that to 1/3. All right, so I need to take 1/3 and do what with it? For those of you who said multiply by 1,200, good job. And then you get 400. All right, next one. All right, Craig has a 6-sided number cube. He rolls the number cube 250 times and records his data in the table. What table is right here? Based on the data shown, the probability of rolling which numbers have a larger theoretical probability than the experimental probability. So the theoretical remember, there's 6 sides on a die, and I can only roll one number at a time. All right, so theoretical is 1/6. I need to take 1/6. Whoops. Sorry. 1/6 and multiply by 250. And that'll give me, it's 41.67. It doesn't come out clean, so I would just truncate this to like 41. So think of it as just truncate it to like 41. So which ones are less than, so the theoretical probability needs to be larger than the experimental. So which ones are less than 41? So this one, this one, this one, and this one. So 1, 4, 5, and 6 are all less than 41. All right. Several students conducted a simulation where a standard coin was tossed several times and the results were recorded in a table. Which table shows an experimental probability of landing on tails that is the closest to the theoretical probability of landing on tails? All right, so theoretical probability of landing on tails is going to be, we should all know this by now, but it is 1/2. So I'm looking at which one is the closest to 1/2. All right, so now I was first doing this. I just added up the totals real quick. This one is 45. This one is 67. This one is 19. And then this one is 142. All right, and so I'm looking at tails. So 18 over 45, 32 over 67, 8 over 19, and 64 over 142. All right, so go ahead and check in your calculator and see which one of these is closest to 50%. All right, so if you plug all of them in, you'll see that this one is 47%, which is going to be the closest, so it's going to be B. All right, so here we are defining the law of large numbers, and we've done this quite a few times, so hopefully you guys understand the concept by now. So I am going to say the more trials we perform, the closer and closer the experimental probability gets to the theoretical probability. All right, Sarah flips a coin 10 times. She lands on heads 6 times and gets tails 4 times. If Sarah flips the coin 100 more times, she should expect her experimental probability to get closer to what? We literally just did this question, so. %50. Whoops. My 5s are terrible. All right, and that's because 50% because that's the theoretical probability. Did not mean to do that. All right, let's move on to the next one. All right, so this one, we are looking at histograms again. Hopefully you all remember histograms. That's one of the reasons I threw in that data cycle review. I think there should be a histogram or 2 on the test. So you need to remember how to do these. All right. So Cosmic Inc. is a software company with 30 employees. The ages of their employees are displayed in the histogram below. Using the histogram below, answer questions 13 through 15. All right, so the first thing I want you to do when you have the histogram to make it a little bit easier on yourself is I want you to go ahead and count the frequency. All right, so first one is 1. This is 13. This is 11. This is 4. And this is 1. So then you don't have to go back and count every single time and then risk the chance of making a mistake. It's like, okay, I already wrote down what the frequency for each of these is. I just have to go back and check the number, and I don't have to, you still have to look at the graph, but I don't have to look at the graph every single time and determine. It's like, I already know what the frequency is for each interval, bin, or class. All right. 13. Based on the histogram, what is the probability that an employee is between 20 and 29? Right, so we're looking at this section right here, right? Right. So that's 13 out of how many employees? 30. So 13 out of 30. All right. So now let's do the next one. What is the probability that an employee's age is 40 or greater? So I need to be 40 or more. So that's going to be this interval here and this interval. Because 40 or more, remember, so if it says 40 or greater, so think about 40 or greater, 40 or more, or if it says at least 40, these are all saying it needs to be 40 plus, 40 and up. All right, so I'm just going to section that off. So I have 4 right here and then 1 right here. So that's going to be 5 over 30, which is, I can simplify both of those. 5 divided by 5 is 1, and then 30 divided by 5 is 6. So that's 1/6. All right, next question. I'm going to erase this real quick. All right, based on the histogram, what is the probability that an employee will be between 20 and 39 years old? So for that one, I need to look at this interval and this interval. So both of these I need to look at. So there's going to be 13 and 11. So that's going to be 24 over 30, which is 4/5. Because 6 goes into each of those. 6 times 4 is 24, and then 6 times 5 is 30. All right. Now, let's move on to this next part. What is the theoretical probability of selecting a... Well, let me read the scenario first. A bag contains 10 marbles, 4 red marbles, 2 blue marbles, 1 green marble, and 3 yellow marbles. What is the theoretical probability of selecting a red marble? All right, so 4 red, so that's 4 out of 10. And both of those are divisible by 2. So that's going to be 2/5. My 5s are really bad. 2/5. All right. Next one. What is the theoretical probability of selecting green or blue? All right. So green or blue means I need to look at both green and blue. So there's 1 green and plus 2 blue. All right, so that gives me 3. That's over 10. So 3/10. All right, last one. We're almost done. All right, so the results of spinning the spinner below 30 times is shown in the table below. For which section of the spinner is the experimental probability closer to the theoretical probability? All right, so let's say blue. Let's do theoretical over here. Write that in the different color. It's theoretical, and then blue. So that's 2 out of 8, which is 1/4. And then red is the same, 2 out of 8. Green is 3/8. And then yellow. Just gonna pick a yellow real quick. Sorry, this is all scrunched up. All right, that's 1/8. All right, and now I am going to calculate the probabilities for our experimental data. So I get 12 over 30. I'm also just going to simplify these like super quickly. So 6 goes into both of those. So that gives me 2/5. My 5s are really horrible. All right, so blue, that gives me 6/30, which is 1/5. Red is 10/30, which is 1/3. And then yellow is 2/30, which gives me 1/15. All right, so I need to think about which one is closest. All right, so this is, I'm also just going to reduce these. All right, so these are both 1/4. Makes it a little bit easier. All right, so which section of the spinner is the experimental probability closer to the theoretical probability? So which one of these here, is closer to what I expect here, right? So I'm looking at them. All right, 1/8 and 1/15. I know 1/8 is 0.125. I don't know 1/15. I want to say it's like 0.7 something. I should just gonna double check. It's actually 0.067. All right, so I know that one's probably not going to be it. All right, let's do green. So 3/8 is 0.375, I believe. 0.375, yes. And then green is 2/5, which is 0.4. All right. And then let me check red and blue. So 1/3, 0.3 repeating, and then 0.3 repeating versus 0.25. And then 20%, well, 0.20 to 0.25. All right, so if you do 0.40 minus 0.375, it's 2.5 away. Every other one is further away. So it's going to be green. And I'm going to write it in green too. All right, so I hope all of this makes sense. I'm going to post an additional video going over some of the core concepts of this unit to help you out a little bit more. If you do have any questions, just shoot me an email. I said an email. Shoot me a message on Schoology or try to ask me before we take the test. All right, I'll see you later. Bye.